Okay, so now if we just go ahead and add these, we have 4. 1 times 4 is 4, plus 4 times 1 is 4. So we have 4 plus 4 equals 8 total electrons. Okay, and then we want to divide that by 2 to get the number of pairs we need to draw this. So 8 divided by 2 gives us 4 pairs. Alright, so I know that this has 5 atoms total, 1 carbon and 4 hydrogen, and if you know these different geometries, you would know that tetrahedral is the only one that is going to have 5 atoms. So I would put carbon as my central atom. Tetrahedral structure is 1 up, 1 off to the side, 1 coming out at us, and then 1 going behind. And so I would draw these like so. And I would count my pairs to make sure it matches. So I have 1, 2, 3, 4, and that matches my calculation here. So I know I've drawn it correctly. Now the other thing that always goes along with these is the geometry, which we've already talked about. So I'd label the geometry as tetrahedral. Okay, and the angles, you have to know the angles. I know that the angles for something that's tetrahedral is 109.5, and that's all of these. All of these are 109.5 away from each other, so I'd put 109.5 on this. And then my polarity is the last thing that always goes along with this. And since this is symmetrical or even on all sides, there's no electrons being hogged on one side or the other, we would call this nonpolar. Okay? So that is all there is to drawing. The last thing is kind of 10, 11, and 12 are kind of put together. And so let's go back here. I'll just erase this slide. And let's talk about kind of the last big question on the test. And what I'll have is a word equation. So something like lithium plus water makes lithium hydroxide and hydrogen. Okay? And what I'm going to ask you to do is I'm going to ask you to write the formulas, then balance it, and then answer some questions about the balanced chemical equation involving the mole, involving the stoichiometric calculations that we've done so far. Okay? And so we would write the lithium is just an element, so it'd be Li. It's not a diatomic molecule. It's a solid. Water, H2O, that's a molecule that's always going to be a liquid. Okay, lithium hydroxide, this is a ionic compound. Oops, lithium hydroxide, LiOH, this is a positive one, and that hydroxide is a negative one, so it's just 1-to-1 ratio, so we just get LiOH. Plus hydrogen. Hydrogen by itself is a diatomic molecule and will always bond with itself, so we'll put H2 here, and we know that's a gas. And this one is going to be aqueous. Okay? So on your test, you'll have the solubility chart that we used that tells you if something's soluble or not. You'll have the polyatomic ions. You'll have the mole chart for your mole calculations, your last table. Okay, so we'll go ahead and balance this. We see that there are 3 hydrogens and 1 oxygen. So if we put a 2 in front of this guy, it gives us 2 waters. Okay, and so we put a 2 here and a 2 with lithium, and I think we're balanced. Okay, and so from this, I might ask you a couple different equations. First, I might ask you what type of reaction is this, and that would be information from chapter 11. So you would need to know that synthesis, double replacement, single replacement, combustion, and the last one is the decomposition. Okay, so you have to be familiar with these. This one right here, lithium replaces the hydrogen, so this is a single replacement reaction. We know that. I might ask you to make the mole ratios. Mole ratios is what we did for chapter 12. Okay, so the mole ratios would be using the balanced chemical equation, so maybe 2 moles of lithium over 2 moles of water. Another one might be 2 moles of lithium over 2 moles of lithium hydroxide. And the last one, 2 moles of lithium over 1 mole of H2 gas. Okay, and of course that was just distributing it out from the first. You would still have to go from this one and then to this one, make those mole ratios. I might ask you to do a stoichiometric calculation using conversion factors and mole ratios. So if we started out, let's say I give you 80 grams of lithium, I might ask you to calculate how many grams of hydrogen that would be, or how many grams of lithium hydroxide we would get. Okay, and so we'd start out with our 80 grams of lithium. From here, you know that grams of lithium has to go on bottom. You just use your periodic table for grams. It would be 6.941. 1 mole of lithium goes on top. So if, let's say I'm going here, I'm trying to figure out lithium hydroxide. Then we'd have to use a mole ratio. So we'd have 2 moles of lithium to 2 moles of lithium hydroxide. Okay, and if we're going to go to grams of this, then we'd have to put 1 mole of lithium hydroxide, and we put the grams on top. So lithium is 7, oxygen 16, and hydrogen's another 1, so about 24.69, I think that is. And somewhere close, don't quote me on that. Now all we'd have to do is take the 80 divided by 6.941. These cancel out, and then we'd multiply that answer by the molar mass of lithium hydroxide, 24.69. Okay, so this is what we've been doing. This is we haven't tested over this, so this will definitely be a large question on there. And then of course the limiting reactant one. So it'll be something. I'm going to erase all this. There we go. So the limiting reactant one. So if I have 2 lithium atom, or 2 moles of lithium, and I have the 2 water, and I want to know which one is the limiting reactant, I have to take them both to moles. So I'll give you 2 different quantities, maybe 25.5 grams, and maybe this is 16 grams, and it wants to know which one of these is going to stop the reaction, which one's going to be the limiting reactant. You have to take them both to moles first. Grams, you have to go grams to moles, and you do the same thing for the other one. Grams to moles. So lithium is that 6.941. Water is 18.0141. 1 mole goes on top of both. Get my calculator here. So we'd have 25.5 divided by 6.94. So we get 3.67. And then 16 divided by 18.0141. We get 0.888. Now this is not just because this one's less. Remember, that's not the case. We always have to use the mole ratio. Okay, so we pick one, and this is moles of lithium. This is moles of water. Okay, so we pick one. I always pick the first. Moles of lithium, and it's going to be 2-to-2 ratio. Moles of H2O. And so we are basically going to get 3.67 moles of H2O is what we're going to need, because moles of lithium cancel out. So since we obviously can see that we don't have nearly that much water, that's a problem. So we know that since this is greater than this guy, this would be a perfect reaction. We'd have to have the same amount of moles. So this would be our limiting reactant. Okay. And then the last thing on the test is a chart from chapter 10. Okay, so it's going to be 10 problems of calculating using 6.02, using each one of the conversion factors. So it's going to be a table, and there's going to be some given numbers and some that aren't. Okay, and you're going to have all the table filled in at the end. Okay, so this one is liters, this one is representative particles, this one is molar mass, this one is maybe a given mass that it's wanted, and then this is the formula right here. So I'll do an example of this one. Make sure you show your work, because if you get it wrong and you show your work, I'll still give you points for at least having it. Okay, so maybe our formula is water, H2O. We know the molar mass is 18.0141, I think. And maybe I give you the amount of liters in this case would be X'd out. Liters only works with a gas unless you're using density. So maybe I tell you we have 4.2 times 10 to the 12th representative particles, which in this case would be molecules. Okay. So the number one would be you'd be calculating the mass up here. So you would take your given number, which you can't use molar mass as your given number, so you'd have to use representative particles. So you'd use 4.1 times 10 to the 12 molecules of water. On bottom, you'd have to use 6.02 times 10 to the 23rd to cancel out molecules over 1 mole. Okay. Oh, and there's another line here that would say moles. Okay, moles. And so from here you could calculate the amount of moles. We could go ahead and do this one. Let's do that real quick. 4.2 divided by 6.02 equals 0.6977. And that would be times 10, and so 12 minus 23 is going to give us a negative 11. Negative 11. So we're going to make this bigger and make it 7.0, because there's only 2 sig figs. I will be looking at sig figs. Times 10 to the, made this bigger, make this smaller, negative 12 moles. So not very many. So up here, I would go ahead and write 7.0 times 10 to the negative 12 moles with the unit and the correct scientific notation in sig figs. And then I could take that and go to mass. I could either do another step here, or I could just start out with this answer and go to my next one. So it's kind of, you choose what your given number is to calculate whatever is left. Okay, your blanks. So 1 mole of water, we know the gram is 18.0141 grams. So we take 7.0 times 18. So we get 126.0987, and that would be to the 10 to the negative 12th still. So we'd move this over 2 times, 1, 2, so it'd be 1.3 times 10. We moved over 2 times, made it smaller, make this bigger by 2, so that would be to the negative 10th grams of water. Okay, and you don't really have to box it in, you just move it up here. So it won't have a question mark obviously right there. You would write 1.3 times 10 to the negative 10th